number 2 again. Right. Okay, so the first thing that we will see is permutation, right? So permutation is kind of, you can say, arranging something in slots, right? So or you can say all the possible way that you can arrange something. That's nothing but permutation. And here basically you are arranging something in a slot. That means the order matters, right? So you are not choosing something. You are kind of fitting something into a slot, right? So the first example can be lock password of 2 digit or 3 digit, right? If you can say if you forget the password of, let's say, suitcase, that is 3 digit, then you can't say like I'm choosing a number. Like it's you are not choosing a number, you are kind of trying all the permutation of 3 digit 0 to 9, right? So in that case the repetition is allowed, right? So first case is nothing but repetitions are allowed. That means if you choose like 0 to 9, let's say you choose 9, then again you can choose 9 here, right? There is no problem with it. In that case the total you can say permutation would be 10 to the power 2, or to be more generalized, n to the power r. So n is nothing but the total options we have in our hand. That's nothing but 0 to 9, that is 10 options we have. And r is nothing but the slots, right? That we need to fill out using this n options, or you can say n things, or n digits. It can be anything, right? So it's n to the power r if repetitions are allowed, right? Because 0 can be merged with 0 1 to 0 to 9, then 1 can be merged to 0 to 9. So 10 plus 10 plus 10, that's nothing but 10 to the power 10 to the power 2, or 10 into 10, right? So simple formula: permutation with repetition. And if without repetition, so the simple would be, as the Olympic is going on, gold, silver and bronze, right? We cannot give gold to two person, right? So there this repetition is not allowed. Let's say we have three racers, A, B and C, three participant, and there are three places only, right? Either A can win gold, B can win silver, then C will definitely need to like go home with the bronze, right? So there is no option. Repetition is not allowed. A cannot win gold, silver and bronze, all three, right? So repetition is not allowed. So if you choose A and C to the silver, then B is by default bronze. So what is 3 to 1? So to fill the first slot, we have three options: A, B or C, right? Whatever the option you choose, if you choose A or B or C, you have just two options left, right? So if you take this example, if you choose that B won the gold medal, then you have two options for silver: A or C. One of them you choose, then you have just one option left, right? So 3 to 1. If you take one more example, let's say there were five racers or five participants, and there were three places, right? One, two, three. Yeah, gold, silver, bronze. Then how many permutation you will have? This is without repetition, right? So for first you have five, you can say options. Anyone can win. Then one is like when won the gold medal. Now only you have four options multiplied by three. So here, this would be the answer of your permutation without repetition. And to generalize it, we have this formula: n factorial divided by n minus r factorial. And whenever like we need to find out 5p2, you don't use this formula. 5p2 is nothing but 5 into 4, right? Because it's 5 factorial divided by 5 minus 2, 3 factorial. So 5 into 4 into 3 factorial. This 3 factorial and this 3 factorial will cancel each other, right? So whenever you need to find the permutation with repetition, just take the number and multiply like in fashion of this factorial: 5 into 4 into 3, up to how many times? Two times. Here 2 is given, so two times, like that, correct? And this is like simple method. If we have like repetition is allowed, sorry, repetition is not allowed, and if we have slots to fill, the options will be one less than left one. 5 into 4 into 3, like this. Correct? And this is the formula, the generalized formula to calculate this permutation without repetition. Right? Okay. Next is combination. Combination is nothing but you have some options. Sorry. right? You have some options and you need to choose. Let's say you have n options and you need to choose r out of it, right? Here either the permutation is repetition is allowed or repetition is not allowed, right? So what I mean by repetition is, let's say you have three models of bike, right? In India, one second, Khalid, bari hai. Right, let's say you have three models of bike, right, in your hand, that Honda, Bajaj, and TVS, right? Now you are, now if I see you, like you can choose two of them, like two model out of it, but and repetition is all allowed, right? If you choose two Honda, that's fine. If you choose two Bajaj, that's fine. If you choose two TVS, that's fine. Then how many repetitions, how many options, like how many ways I can do this? So it's nothing but r plus n minus 1, or n plus r minus 1 divided by r factorial n minus 1 factorial. This formula can be achieved using this formula, right? So there are basically six ways, either to Honda, Honda Bajaj, or Honda TVS. So see, if I say I choose Honda in Bajaj, or I say I choose Bajaj in Honda, they like here the order does not matter, right? So if I say my first bike is Honda, second bike is I have two bikes, one of them is Honda, one of them is Bajaj. Then if I say one of them is Bajaj and one of them is Honda, the meaning is same similar, right? So here the order does not matter, right? So that's why we have not bh here, we have just hb here, correct? Because order does not matter, hb is similar as bh, right? That's why we have six ways here. Now if repetition is not allowed, right, you need to choose specifically two different model of bike, then there would be just three ways: hb, ht, and bt. Because two tvs is not allowed, two Honda, two Bajaj is not allowed, so these three would be gone. Nothing fancy, right? And the formula is that we know, this is the formula that we already know, that ncr formula is n factorial al factorial into n minus r factorial. This is new one, right? So if repetition is allowed, the formula is quite, you can say, different: r plus n minus 1 factorial, and here we have n minus 1 factorial. Here we had n minus r factorial, right? So this was all about permutation and combination. And in probability, the most useful formulas are, I guess I have noted down this one. So the first is simple formula, that classical formula of probability, it's number of favorable events divided by total events, right? So this is the classical formula. In this naive definition is true only and only if the all the events, right, all these favorable events, or you can say all the events in the experiment, are equally likely, right? The probability for happening any of them is similar as others, and then and only this formula you can apply, correct? So and okay, pab is nothing but for, okay, pa, okay, why I have written this? Okay, the multiplication, okay, cool. Let's go. Okay, see what's the meaning of this is, PA intersection B is PA into PB. So what they are saying is, for independent events. Let's say I say I'm doing two experiment. One is that I got a head on a coin, and second is I got a two on a dice. So what's the probability of having that? So it's nothing but 1/2. It's nothing but getting a head on a coin, and 1 by 6 pb would be nothing but 1 by 6. It's nothing but getting a 2 on a dice, right? So it's simply multiplication. If events are you can say independent, and if I say like both event occurred, right, both event occurred, right? So that that one student got marks like greater than something in maths, and also greater than something in physics, then what's the probability, right? Or he got pass in both the subject. So it would be nothing but the multiplication of both, because it's independent events, right? This is very useful, law of total probability, LOTP. What it is saying is, I guess I gave one example of that bulb, right? So let's say I have like some manufacturing units like b1, b2, b3 up to bn, right? And all manufacturing units are different, right? Some of them are using a modern technology, some of them are using like some very old, right? And even the bulbs that they are producing is also different. The number of bulbs, or you can say number of screws, let's say, right? And any item they are producing is different, right? So this way, this is nothing by total sample space. So if there is a, let's say I am making some electronic part, right? So either it can be from factory number 1, factory 2, factory 3 up to factory n. So this is like it is not possible that it's outside of sample space, right? So it should be made at any one of the factory, and the probability that it is made at that factory is also different, because every factory is producing different number of that you can say register, or let's take capacitor. Like if you give more voltage, it converts into firecracker, like that, right? And the blast of capacitor is very satisfying. So let's take so this capacitor can be made at any factory. So it's having some prior probability. So it's nothing but this thing: P of B1, P of B2, P of Bn. So this is the prior probability, that this is the probability that bulb is made at factory 1. This is the probability that sorry, capacitor is made at factory 1, factory 2, factory n, right? Now event A I am defining as like that capacitor is faulty, right? So this event A is nothing but the capacitor is faulty. So how can I find out that probability that I choose like a random capacitor out of a box and it is faulty? So that probability, it depends on this thing, that that total of probability says that that probability is total of like A intersection B1 plus A intersection B2 up to A intersection Bn. That's nothing but this thing plus this thing plus this thing up to this thing, right? This is the simple intersection. If I take A intersection B1, I got this thing, then this part, then this part. If you sum it all, you will get the probability of A, right? And I using this conditional probability formula, I can write A intersection B1 like this also, right? Probability A given B1, that means what is the A is nothing but my capacitor is faulty. So what is the probability that capacitor is faulty given it is made at factory 1 multiplied by what is the even what is the probability that it is made at factory 1, that I need to consider, right? Because it is different for all the factories. Next, capacitor is faulty given it is made at factory 2, because all the precision or you can say success rate of factory is also different. So this probability will also be like different from each other. A given B1, A given B2, A given Bn. A very precise or very automated factory would have like less chances of faulty capacitor, right, compared to manual one. So this is the total raw low probability, and this number of you can say independent or this partition of a space can be different in different problems, right? So just keep in mind, and this formula we are going to use here. Uh, yeah, in the bias law, this conditional probability. Whenever say I have observed that in a formula, this is sometimes this is trivial, and these two are mostly trivial or easy to derive, but this thing is always a monster, and we thought like we got that, but it has something to do, right? And mostly like if it is very tricky question, then most of the time this formula, just think of this formula. If you can think of this kind of mutually exclusive events, you can say, or the partition of a sample space, and think in that term, like if I can use this total law of total probability here, right? So P of B, if I can use this formula to derive this, right? Okay, next, bias rule, or you can say the conditional probability. So, conditional probability A given B. So, that we already discussed. The condition always that you can say modify your sample space or narrow down your sample space given this condition. What is the probability that A will happen? So, this is always true. This is ground truth that I have given. This is kind of an observation that is already done. You cannot deny it, right? So B is already done. I'm saying it's even, right? I'm saying like it's even. The number on a dice is even. Now you need to guess what it is: 2, 4, or 6. What's the probability of 2? It would be 1 by 3, not 1 by 6, because even is given, right? It's even, that's for sure, right? Okay, so the first was, say there are three different formula that we are going to use. This is the basic formula. I guess I have not written here. The basic formula of conditional probability is P of A intersection B, and in division, whatever the next is given, the condition is given, that we need to divide. P of B. So this is the formula number one, not very much used. This is the second formula of bias. So you can say from bias rule, this is the second formula. B given a probability of A given by probability of B. And this is the third formula or odds form of bias rule they say. This is nothing but you don't need to use. What we are doing is we are just using this kind of this formula total probability, and we are dividing A basically. So first we are taking what is the probability of B given A, and what is the probability of B given A complement. So if you take A and A complement, it is the total, you can say total space, right? A plus A complement represent the total space, mutually exclusive basically, right? There is nothing common between A and A complement. So that's why that way we have written this probability of B in this fashion, right? Okay, so this formula, this three formula are very useful, one, two, and these three. And most of the time our energy and our time would be to find out the probability of B. Okay, with that, let's jump on to our first question. Uh, okay, and I guess we should solve like as along, and if we find any problem, then we will see that you can say solution, right? Okay, so a random bit string of length n is constructed by tossing a fair coin n times and setting a bit to 0 or 1 depending on the outcome head and tail. Right? So if we get head, it's 0. If we get tail, it's 1. Like that. Respectively, the probability that two such randomly generated strings are not identical is, right? Now, this can be solved in two ways. First is find out all the possible ways in if the length of a string is n, that strings are not identical, but it would be very cumbersome and not easy at all. So what we will do, we will take the total probability, that's nothing but 100%, and we will minus what is the probability that two strings are you can say similar, right? That n bit string, both strings are similar, right? That probability is nothing but if I have had here, then what's the probability that I get head here, right? So it's nothing but 1 by 2, right? Length of say we have this random bit of length and string, right? So what is the probability that it is matching? So it's 1 by 2. Then again, let's say I have tail here, so what is the probability on next string I also have tail? So 1 by 2, right? So 1 by 2, 1 by 2, 1 by 2 n times, so it's nothing but 1 by 2 raised to n. So 100% divided by minus 1 by 2 raised to n. 100% is nothing but 1, so 1 minus 1 by 1 by 2 raised to n. D is the answer. Correct. So sometimes, like if it's not identical, find out the at least that event happen. At least I get a one, like that. So just convert it into different problem there, which is easy to solve. Right. Okay. Any doubt, guys? How we got this? And say one hack I want to share is, let's say you don't get this idea, not identical, and you want to go into what you can say, you have the plenty of time, right? Because before it we can't do anything, so we will utilize up to it, and this paper would take definitely like more time, right? So what you can do, just take simple example, a length of n they are saying, no? So just take n equal to 2, right? So the first string can be either 0 0, 0 1, 1 0, or 1 1. There are only four possibilities for first string, and so for the next string, you can say second string, there are like four possibility only. Now there are how many you can say like how many combination you can make out of this four two-bit string? There are 16 possibility. If I get 0 0 here, it's possible that on second string I get 0 0 or 0 1 or 1 0 or 1 1. If I get 0 1 on first string, right? Because it is the bits are set by tossing a coin, head or tail, right? So it is if I get 1 1, then it is possible that I got 0 0 0 1, 1 0 or 1 1. So there are total 16 possibilities, right? So out of 16, how many you can say events are saying that two strings are similar? There are only four, right? If I get 0 0 here and 0 0 here also, so it's 1, 2, 3, and 4. So four are just matching, and rest all of that is nothing but 12. How we got 12? If I get 0 0 here and if I get 1 1 1 0 or 1 1, so it's 3. For 0 1 again I have 3, 0 0 1 0 1 1. Like these three events that 0 1 is not matching, two strings are not matching or not identical. So if I have n equal to 2, I'm getting so this is I'm getting 4 here. 4, that is nothing but the matching case. 12 is nothing but the not matching case. So what's the probability? 4 by 16 is nothing but 1 by 4, and 12 by 16 is nothing but 3 by 4. Now, I just need to put n equal to 2 in option A, option B, option C, and option D. Whoever give me the answer 3 by 4, it's the answer. So only in D you will get 3 by 4. 1 minus 1 divided by 2 raised to n. And n is nothing but 2. So 1 minus 1 by 4 is nothing but 3 by 4. Array yaar. Right? Understood, guys. If you're not able to solve like using some intuition, or if the problem is very difficult, then definitely you can just take the smaller example, that just take n equal to 2 and find out like what is the probability that strings are identical and not identical, and just put n equal to 2 in all of this, right? And any doubt, guys?
This will not work if the events are dependent, right? If there is conditional probability or something like that. If it's
In
independent,
conditional probability you need to know like all the
yeah,
crux and how to deal with it basically. But this kind of simple problem can be tricky
yes,
also, right?
yes, nice, nice. I will give you.
Even I first I thought it would be 1 by 2 raised to n. The idea behind my thought was, if it is h, what is the probability that I get t here? It's 1 by 2, right? If I get t here, what is the probability that I get h here? It's 1 by 2. Not matching, no, bit is not matching. 1 by 2, 1 by 2, 1 by 2, 1 by 2 raised to n. I thought this is the answer, but then I realized here it can be t also, right? If one bit is not matching, the strings are not identical. Correct. That's why like these simple problems can be tricky also. But if you work out the small example, then there is no chance to make a mistake. Okay, second problem, what they are saying is for each element in set of size 2n. Okay, so we have some set of size 2n. That's fine. An unbiased coin is tossed. How many times like they will toss a coin? The 2n coin tosses are independent. So I am tossing a coin for 2n time. Okay, that's fine. An element is chosen if the corresponding coin toss was a head. Right. So if it is a head, then I will choose one element out of it. That's fine. The probability that exactly n elements are chosen. So what they are saying is n elements are chosen. That means there are n heads. So how many heads I am getting? N out of 2n. So if I am tossing a coin 2n times, so both everything is nothing but the Bernoulli experiment, right? Coin tossing, and I am doing it for the 2n times, right? So there, and I now I'm asking like how many times I will get n heads. It's that example that we give that I gave about the Virat Kohli, right? Out of 10 coin toss, what's the probability that he will get 6 heads if he's saying like head all the time, right? So that's the same thing here. Out of 2n head I'm getting n heads. No, sorry, out of 2n coin toss I am getting n heads. So there are n possible ways to choose n heads out of 2n, right? So 2n cn is the total number of ways I can choose n heads out of this 2n slots, multiplied by p. So what is the probability of that I get head? 1 by 2. And how many I need? N. Rest, how many are rest? 2n minus n. So n is remaining, and that has to be tail. So 1 by 2 raised to n. So this would be the answer. 2n cn divided by 2n 2n, so it's 4n. So 2n cn 4n. A is the answer. Right, so this is the nothing but simple binomial, you can say, event problem. right? So they can ask directly like this if they don't want to complicate, but it would be complicated if they ask like this thing that I am throwing a dice for 100 times, then what is the probability that I get this thing 12, or let's say 20, 26, right? Because if you get 6, I guess it makes some sense in ludo, right? You get your that piece out, right? So what's the probability? So how will you solve that? Anyone, guys, just help me. I want to make this interactive actually, right? So 100 dice throw I'm doing, and I'm asking 20 times this 6, uh, right? Exact 20 times, huh? 80 times I get like other than 6. Anyone, guys? Anyone? 100 dice throw.
100 C20.
Okay, go on. Perfect. Then
You want to get 6 as a number? 1 by 6. 1 by 6.
yes, yes, 6 is a number that I got 6 20 times, and 80 times other than 6.
1 by 6 raised to 20.
Okay, 1 by 6 raised to 20. Go on, correct.
5 by 6 raised to
Yes, that's what I want to confirm. Yes, that this P and Q can be different also. Raised to 80. Correct. So this would be the probability that I get 20 time this 6 on a dice if in the 100 dice throw. Okay, guys. So let's jump on to next conditional probability. Okay. So this is the simple axioms of probability that we saw. Let A and B any arbitrary event. Then which one of the following is true? Right. So this is only true if it is independent. A and B are independent. A union B. This formula is not correct because we have something like this. P A in A intersection B. What happened? Okay, right. So this is only possible if this is true. If this is zero, right? So this is not true. This is not true. Always A this okay. This is exactly different. No, the A condition B or A given B is A intersection B divided by P of B. So this is not true. This is true. Right, because this can be either 0 or greater than 0. So if it is 0, then it is equal to, if it is greater than 0, then it is less than or equal to A union B. So this is the simple axioms of probability that we saw, right? One of the axiom. Okay, now what we have, let P denote the probability of the event T given PA equal to 1, PB equal to 1 by 2. What's the values of PA given B and PB given A? Okay, so this can be solved using the formula or intuition also. PA is 1, right? So this is 1. This is sample space, or you can say universal truth that this event is happening. This A can be something like this, that on a throw of a dice, I got 6 or less. Like while going to batting, I score 0 or more, right? So it's always true, right? So A given B. So whatever the value of B I have, probability of A would be 1 only. So this is the answer, right? And B given A, right? So B given A, so A is happening all the time, right? So the and in A is like in the denominator, right? If you think in formula, right? So this has no effect on B because A is happening every time. So what is the probability of B? It's nothing but 1 by 2. So 1 and 1 by 2 is the answer. So if you put in formula, then also you will get the answer, but this can be solved directly also. So if you put in formula 1 by 1 as a good student, then also you get the answer. Right? Let's have some fun. Next is looking beautiful. Okay. Box P has two red balls, three blue balls, and box Q has three red balls and one blue ball. Okay, so I have box P, I have box Q, some red balls, some blue balls. Right, so I have how many red balls here? Two, three blue balls, three red balls, and one blue balls. Cool. A ball is selected as follow. One, select the box. So either P or Q. So it's 1 by 2, 1 by 2. Let's see. Choose a ball from the selected such that each ball in the box is equally likely to be chosen. Cool. So we can use the naive probability formula. Uh, The probabilities of selecting box P and Q are 1 by 3 and 2 by 3. Okay, cool. So the probability is different for choosing box P and box Q. Given that a ball selected in the above process is a red ball, the probability that it came from the box P is, so what they are asking is probability that it's a red ball and it has come out of P. So what's the value of this? R given P, right? Okay. They ask like different. Okay, they ask the otherwise. What they are asking is given that a ball selected in above process is red ball, so red ball we have already chosen, right? So it is given that ball selected in the above process is red ball. Now we need to find out the probability that it came from P. So P given R they are asking, right? So how can we solve that, right? P given R that we need to solve, right? So if you think this can be solved using both the formula that P intersection R divided by P of R, like that, or if you put the Navi Bayes formula, that's also possible, right? So just a second, let me go to this. Have I solved in both ways? Okay. So see here, you can directly jump onto like using the formula, but sometimes it would be not possible to, you can say, uh, understand, or you can say make sense of this all A, B, and R and P. So it's always like good thing to just assume all the events, give some name to event, that A is nothing but ball is picked up from P, B is nothing but red ball is picked up, then C is nothing but, let's say, A complement, ball is picked up from Q, right? Now if you put the formula, then it will make sense. P of A given B, that's nothing but the it is chosen from P given it's red, it's probability of B given A, probability of A. So these two are very, you can say, easy to understand. Then always this term would be, you can say, monstrous. So probability of B, right? So what is P given A, B given A? That is the ball is picked up, sorry, the red ball is picked up given it is from P, right? So now A is given, right? So condition is A. What is the condition? That ball is picked up from P, right? So it is true. Now I have just one box and I have five balls. So how, what is the probability that I choose red? B is nothing but choosing a red, right? So it's nothing but 2 by 5. So this is trivial, this is 2 by 5. Then what is the probability of A? That ball is picked up from P. So it is already given in the question that it's 1 by 3. Right? So this is also given. Now what is the probability of B? That red ball is picked up. Right? And there is no condition given, right? So you can this is the completely random experiment. So there are two ways that you can choose a red ball, either from box P or either from box Q, right? And I have just two things, no, P and Q. So it is something like this, yes or no? Exclusive event, either it is from P or either it is from Q, and it is making total sample space 1 by 3 plus 2 by 3 is 1, right? And I am choosing a red ball, right? So using the total or you can say law of total probability, that probability that it is a red ball, it's nothing but a probability that it's a red ball given the box was P, multiplied by what is the probability of P, right? Plus probability that the it is a red ball given the box was Q, multiplied by what is the probability that box is Q, prior probability, right? So I can write something like this. So R given P is 2 by 5. If it is box P, then total out of 5 ball I have 2 to pick up, right? Right. So 2 by 5 multiplied by 1 by 3. 1 by 3 is nothing but probability of choosing box P, plus probability of R given Q. So it is nothing but the Q is given, right? Box is Q. Then what is the probability of choosing ball R? Sorry, ball R, not red ball, 3 by 4. Out of 4 I have 3 red ball, multiplied by 2 by 3, right? So that's what I have written here, but in, I guess, a different format. Probability B given A and B given C. So C is nothing but ball is picked up from Q, right? So if you put all the value, then you get this answer, 4 by 19, right? So think like this probability of B, red ball is picked up. So don't do something like this, 2 plus 3 5 divided by 9. No, because if and you can do that kind of a thing I guess if the probability of choosing P and Q are also similar. Correct? Any doubt, guys? Because this was the kind of introductory conditional probability numerical.
This is name from base theorem, no?
Uh-huh.
Name base theorem, what we call it.
Yes, yes, yes. Naive base. Yeah.
Yeah, yes. So there's one more way of solving this. Probably I'll click the photo and send it on the Telegram group. I
Huh.
can
Just count, no? I know like what you're saying. Just
by
count, no?
automatically by just by the tree diagram way. Do you know
Okay.
that?
No, sorry. Just
So
tell
that's
me.
very much easy actually.
Okay.
So I don't know if I can show it now. It's fine. We'll continue. I'll just post it. I'll just solve it and I'll just post it on the Telegram.
Okay, okay. That would be great,
Okay.
great help. Yes.
I don't want to waste the time now.
Huh, that's fine. Okay, Rajesh, sure. Don't forget, otherwise I will message you.
Yes, yes, I will. I will. I'll
Okay.
make a note of it and
I'm just kidding. Okay.
uh,
Let's take the googly one now. Six number. This was the proper, you can say, deadly googly. Let's see what it is saying. Suppose a fair-sided die is rolled once, right? So we are rolling a dice once. So 1, 2, 3, 4 by 6. Okay. If the value on the die is 1, 2, or 3, okay, 1, 2, or 3, the die is rolled one more time, right? Not for 4, 5, and 6. So again, I will roll a dice 1, 2, 3, 4, 5, 6. Now, what they are asking is what is the probability that the sum total of values that turn up is at least 6, right? So, at least 6 means 6 or greater than 6, right? So, how many ways I can get 6 or greater than 6? So if I get one, then I get a chance. Those they are asking for some, right? So I get a chance, right, to roll the dice one more time. So again I roll. So if I get one, it doesn't count, right? Because one plus one is two less than six. If I get two, it doesn't count. So if I get let's say five or six, it counts, right? One plus five is six. One plus six is seven. So I have even something like this: 1 5 and 1 6. Why I am writing in tuple? Because I rolled the dice, right, twice, two times, right? So again for 2 it would be 4 5 6. For 3 it would be 3 4 5 6. So 3 plus, sorry, 2 plus 3 plus 4, I have total 4 plus 3 7 plus 2 9 events, right? But there is one more catch here, that if I get 6 directly, then what happen on first try? If I get 6, then it does count, right? Because it is at least 6, greater or equal to it should be, no, so it is on also 6, right? So I get 6, so this is also an event, right? This also count in our event, right? That some total value should be turn up at least 6, right? But the probability of getting 6 and probability of getting 1 and 5 is different. What is the probability that I get 6 on a first roll? So it's 1 by 6. Then what is the probability that on my first roll I get 1? It's 1 by 6. And what is the probability that I get 5 on the second roll? It's 1 by 6. Both are independent, so we need to multiply it. So it's nothing but 1 by 36. So these two total, you can say these two probabilities are different, this probability and this probability. So we cannot simply count all the favorable events divided by total events. So what we need to do is we need to count all the probabilities, sum them all, and then answer basically. So what now we will do? We will take all the possible case that sum is greater or equal to 6. So it's 1 5 1 6 2 5 2 4 2 5 like this, plus probability of getting 6 on first time, right? So 1 by 36 1 by 36, all of these events are having 1 by 36 probability. And how many times? 9 times plus 1 by 6. So it's 9 by 36 plus 1 by 6. So I get 5 by 12. Right. So this is the total chance that you will get, or you can say this is the total probability that you will get some greater or equal to 6 given this kind of a, you can say this kind of conditions. Right. Any doubt, guys? Why? Otherwise it was simple. Total 10 events. So 10 divided by how many combinations are there? Just count 6 these are 38. Sorry, it's at 18, 19, 20, 21. So 10 divided by 21 is not the answer, it's 5 by 12. Right? So if all the events are having the same probability, then and only you can say something like that. Number of favorable event divided by total number of event. Otherwise, no. Okay. Next.
Which so we have not used any formula. We just have used equation, right?
Simple. We are just calculating the, you can say, independent probability and then sum it all.
Okay.
Correct?
Mayur, so 36 is taken because you're rolling the dice twice, correct?
Hmm.
6 is a 36 to
Correct.
So,
Correct.
but when you get 6 on the first roll itself, then maybe you're not rolling the second dice.
That's why 1 by 6. No. Hello?
So what is this 36 over here?
Huh? Hello?
36 that you have taken, 9 by 36. So that 36 does not include the count of the first and second dice.
See, all these 9 events are outcome of rolling a dice twice, right? So what is the probability that on my first roll I get 3, and second roll I get 3? So it's 1 by 36. So 9 times I'm having 1 by 36, right? This 1, 2, 3. And this probability of getting 6 only, it's 1 by 6. Right? That's why this 9 times I have, no? So that's why I wrote 9 into 1 by 36.
I think both are separate events, I guess. So we should not combine both. Like, I got what Rajesh is assuming, but I think these two are separate things. So that's why 9 by 36 is a separate one and 1 by 6 is a separate one.
Correct.
Because I was in the impression that if we get 6 in the first roll itself, then we are not going to throw the dice again. So
Correct.
that thing should be somehow minus. There's no condition like that, right? They didn't mention any conditions like that. So we
And
have to
why to minus, right? Because this is all that we want, right? Sum should be greater or equal to 6. Right? So this also count. No, if I say like if you get on a dice greater than or equal to 6, I will give you like 1 or whatever, like 1k euro, like in casino. So this also counts. No, if they say like they you don't roll it twice, like you are not rolling a dice twice, so this probability we should not count. No, because this belongs to this event. No, that's whole idea behind this random variable. And so this is nothing but the random variable you can think of like this. So this x is a random variable, and that random variable is representing all these values, which counts all these events. That's nothing but the sum is greater or equal to 6. So this also counts. No,
we can use 1 minus rule here. Some less than 5, strictly less than 5.
it would be tough, right? Because there would be so many events. No,
I have to calculate a lot of events. Like 5, 3, 2, 1.
Correct.
Yeah.
Okay, let's see if we have that kind of a problem in those 100 questions on gigs for gigs, or that's nothing but get question paper. Let's see. Okay, and the pace I like because it's just 10, 18, and we are done with 6 examples. Great. Okay, let's take the next example. Total law of probability. It is looking like that. Suppose that a shop has an equal number of LED bulbs of two different types, right? And this two, and it's of two different types, right? So either type 1 or either type 2. It's fixed. The probability of an LED bulb lasting more than 100 hours, given that it is of type 1, is 0.7, right? Proper company wala bulb, right? 0.7. And given that it is of type 2, it's zero point 0.4, imported from China. The probability that an LED bulb chosen uniformly at random lasts more than 100 hours. Right. So as you have understood that there are two types. That means my sample space is divided into half, and the probability of type 1 and type 2 is different, right? Now I want to calculate the event is nothing but the bulb is working condition. Let's say working condition, like working more than 100 hours. right? So it's nothing but the total law of probability, a law of LOTP, law of total probability. Okay, so how can we solve that, right? So this is the diagram that of type 1. What is the probability that it's of type 1? 0.5. And what's the probability that it's of type 2? 0.5, right? It is not mentioned. It's of two different type. Either can be type 1 or either it can be type 2, right? And they say, don't confuse like it is the probability that it's of type 1. What they are saying is the probability that bulb is working, right, more than it's working like 100 hours, given that it's type 1. So this is the probability that bulb is in working condition, right? If it is in type 1, so it's zero point 0.7. If it is of type 2, it's zero point 0.4, right? Just a second. Yes. Now, probability of A, the total probability of A, that A is nothing but bulb lasts more than greater like 100 hours, right? Or bulb is good. So it's nothing but probability that bulb is good given its type 1 multiplied by probability of type 1. So LOTP I am just applying, plus probability that it's good if it is of type 2 given its type 2 multiplied by what's the prior probability that it's of type 2. So this is given that probability that bulb is very good given it is given that its type 1 is zero point 0.7 multiplied by zero point 0.5 prior probability of if bulb being of type 1 plus zero point 0.4 for its working given its type 2, and this is the total probability of type 2 zero point 0.5, right? So if the math work out and you get the answer P of A equal to 0.55, right? And basically, what we are doing is we are just considering all the cases that the bulb is working. So it is possible that it's of type 1, and it's also possible that it's of type 2. So if it was type 3, just we had just one more term here, nothing fancy, right? And just hashtag change from easy to medium. Okay, now it will take some time. Yes.
If there were three types, so we will compute it based on 0.50.
Huh, 1 by 3, 1 by 3, 1 by 3. If it's of equally likely, and it is also possible that the bulb being type 1 is different, type 2 is different, and type 3 is also different, then this probability will just change.
So we will just use total log probability.
We will use that prior probability here, correct?
Mayur, what is the reason that you have chosen half? I mean, for selecting
It's not mentioned. Suppose that a shop is an equal number of LED bulb of two different type, right? So it's equally likely, equal number of LED bulbs of two different types.
You chosen uniformly at random last. Uniformly means equal probability.
And uniformly, okay, uniformly we are chosen, no, okay. That also makes sense, no, that bulb chosen from type 1 is equal to type 2. And my final argument would be it's not given. Correct? The probability of it being type 1 and type 2, it's not given. And this uniformly makes sense. Equal number of LED bulbs also makes sense, right? Okay. Next question. This is you can say very good example, or you can say one of the favorite one. The P and Q are considering to apply for a job. This question is also you can say daunting. Are considering to apply for a job, right? The probability that P applies for a job is 1 by 4. Probability that P applies for a job given that Q applies for a job is 1 by 2, right? So by these two lines it's clear that I need to choose one event that P applies for a job, second event Q applies for a job, right? And okay, so if I take those two events that P applies for a job, Q applies for a job, then what is given, that what is the probability, the probability that P applies for a job is 1 by 4. So probability of P is nothing but 1 by 4 they have given. One more thing they have given, the probability that P applies for a job given that Q applies for a job. So conditional probability is given, P given Q is 1 by 2 that they have given. The probability that Q applies for a job given that P applies for a job is 1 by 3. Oh, wow. Q given P is 1 by 3. Then the probability that P does not apply P does not apply, that's nothing but P complement, right? Given that Q does not apply for a job, so Q complement. So this is what we need to find out, right? The first question is really easy if we know like how to approach it, but the approach is quite, you can say, difficult. Let's see how we can solve this, right? So what would be the formula of this? P given C, Q given C, like this. And see, one thing that I want to give, like before solving this problem, is probability of A given B plus probability of this A complement given B is nothing but equal to 1. Right? It's same as A plus A complement equal to 1. That's just the same condition I have given. Right? If condition is not mentioned, it's nothing but the sample space. Right? So if condition B is given, then the probability of A plus A complement is 1. Right? So if I put the formula of P complement and Q complement, I will get something like this. Let me erase this. Oh, where is the cursor? Okay. So if I put the formula P complement and Q complement, I get something like this. Q complement given P complement, probability of P complement divided by probability of Q complement. So calculating this P complement, Q complement is easy, right? Because probability of P is already given 1 by 4. So P complement is 3 by 4. And given this two conditional probability, P given Q and Q given P, we can directly find out probability of Q, right? Just comparing both of them, right? Because uh, P intersection Q is common in both of them, so Q can be worked out, right? So it's easy. Q complement we can find out. So this is easy, this is easy, but this is not easy. Q complement given P complement, so this is kind of a tough, right? Too tough to calculate. So one hack that we can apply is, if we can somehow find out P given Q complement, then we can find out this also. If we get here, let's say, zero point 0.3, so this would be nothing but 0.7, right? Because summation of both, the condition is same, right? Q complement, Q complement. So P plus P complement is nothing but the 1, right? So if somehow I can find out this, then it would be really easy to find out. It would be really easy. And the idea that I got this is nothing but the problem itself, that Q complement given P is already given. I guess Q given P is given, Q given P is given. So I can definitely find out that Q complement given P is 2 by 3. So this is also this is given, correct? So then it would be really easy, because this is already there in a question. P complement is also given in question. P is 1 by 4, so P complement is also given. Now we can say that, right? 3 by 4. So I just need to find out what is the Q complement, and my problem is solved, right? So this is the approach that we need to take. Now it would be really easy, right? Probability of P is given 1 by 4. So what is the probability of P complement that we need here? So it's nothing but 3 by 4. Cool. P given Q. So what is the probability of P complement given Q? So 1 minus 1 by 2, right? This Q condition is similar, right? So what is the P complement given Q? 1 minus 1 by 2, 1 by 2. So if Q given P is 1 by 3, then what is the Q complement given P? 1 minus 1 by 3. It's nothing but 2 by 3. Right? So now we know everything. This Q, C, P, this is done, this is done, this is remaining. So let's find out how can we find out the Q complement. So I just mentioned, right? These two, you can say, conditional probability are given. So there is one thing common in between. It's nothing but P intersection Q, right? Or even you can go easy way, just use the bias formula, right? P given Q is nothing but Q given P multiplied by probability of P given by probability of Q, right? Just use the bias formula. Q given P, QP probability of P divided by probability of Q. So this is given 1 by 2, this is given, this is given. Just find out probability of Q. So probability of Q is 1 by 6. So what is the probability of Q complement? 5 by 6. So this is known, this is known, this is known. Just some multiplication and division, and yeah, we got the answer 4 by 5. Right? And see, if you put everything here, you will get 1 by 5 here. And what they have asked is P complement given Q complement. So how can you find that? 1 minus 1 by 5. 5 by 4 by 5. Correct. So this is the approach that we can solve this, and definitely, if you put this formula that they want to find out this, so this is not trivial. Correct. So you can find out the, you can say, the other part of it. That's nothing but P. Correct. Any doubt, guys, or any question? Hello. Should I move to next question, guys?
Sure, Morgan. Yeah.
Okay. Because even this was not making much sense to me, so please like follow that note. Okay, because they have taken so many equations, 1, 2, 3, 4, 5, 6, 7, 8, 9 equations. Hence, from 7, 8, and 9, they find out something like this. I don't know what utter nonsense they've done.
It looks from the assignment they have got the
See, this is
mathematical
complete. What they have done is just take the question, copy paste, just take a screenshot from Gate Overflow, paste it here, done. This all like exact it is matching with Gate Overflow answers.
You can get some you on if you search on YouTube also you'll get the videos.
Array, even if you type like just first 3 or 4 words, na, you will get the Google answer directly. You'll get the Get
YouTube
Overflow
also
link.
you'll get where there's clear explanation on why this is done.
Okay. Yes. YouTube, they some YouTubers have explained. Yes. Okay, so let's take, and this is for last time. So otherwise, then I guess we will directly face this kind of probability quiz, or like this directly in interview maybe, or screening test. So this is the last time that we are dealing with probability, and I know, like as sir mentioned, na, this is not very, you can say, visual approach you can give to probability. Up to some extent it's possible, but after that you can't visualize probability basically. Okay, so said that, let's take next question. One page of question only. Consider Guwahati G and Delhi D, whose temperature can be classified as high, medium, and low. Right. So, I am reading it something like this. They have given sample space divided in high and medium and low. Right. So let P of Hg, okay, what is this? Denoted the probability that Guwahati is high temperature. H is high, G is Guwahati. PMG and PLG, that's nothing but Guwahati is having a medium and low temperature, respectively. Cool. Similarly, if we use PHD, PMD, and PLD for Delhi, high, medium, and low temperature in Delhi. So the three category of temperature is fixed, either high, either medium, either low, and they have not given like what is the prior probability that if it is not given, then we will choose 1 by 3, 1 by 3, 1 by 3 if needed. Right? Let's see if they have given or not. The following table gives the conditional probabilities for Delhi's temperature given Guwahati's temperature. Right? So given Hg, what is the probability that it's a high temperature in Delhi? Zero point 0.4. Right? Like this. So given, so what they've given, this is the probability for Delhi's temperature given Guwahati. Right? So condition is Guwahati's temperature. The probabilities are for Delhi's temperature. Right? Let's see what they are asking now.
PhD by PhD, right?
Huh?
PhD by PhD is equal to 0.40, right?
Yes, PhD, PhD given Hg,
Okay, 0.40.
zero point 0.4. Yes. Okay, consider the first row in the table above. Okay, now they are explaining. The first entry denotes that the Guwahati has a high temperature. The probability that Delhi is also having a high temperature is zero point 0.4. HD given Hg is zero point 0.4. Similarly, the next two entries are PMD PHG and PLD PHG. Like this. Okay, now let's see what they are asking. It is known that, okay, now what they are asked, say the prior probability for Guwahati is given, that it's 20% chance that the temperature is high in Guwahati, zero point 0.5 that it's medium, and low it's 0.3. So if you sum it all, it's 1. right? Point 0.2, point 0.5, and point 0.3. It's one. Right, so they have divided the sample space into three parts: high temperature, medium temperature, and low. And all three are not equally likely. 1 by 3, 1 by 3, 1 by 3. We don't need to take it. Then the probability correct to 2 decimal place that, okay, now the question start. Guwahati has a high temperature. So probability of Hg given Delhi has a high temperature. That Delhi has the high temperature. What is the probability? Right, hg given hd, they want us to find. Right, so just put the formula. I don't know what this nonsense again is. Okay, so if you put the formula hg given hd, hg given hd is hd given hg, just reverse, take the probability of hg and divide by whatever the condition is given hd. Right, now hd given hg is given. If you think intuitively, this zero point 0.4 is nothing but hd given hg, that Guwahati is a high temperature. What's the probability that Delhi is a high temperature? It's zero point 0.4. So this is given. Probability that it's a high temperature in Guwahati, it is also given. Zero point 0.2. Right, and always the you can say headache is to find out this denominator, probability that it's high temperature in Delhi. Never, like they have not given something like that in all the data, but they have given something like this, that high temperature in Delhi given high temperature in Guwahati given high temperature in, sorry, medium temperature in Guwahati and low temperature in Guwahati. So we can definitely use this, right? So given the high temperature in Delhi, there are only three possibility. That's it's high temperature in either Guwahati or medium or low. So if I use the total probability, so it will look something like this. Total sample space, this is zero point 0.2, this is zero point 0.5, and this is zero point 0.3. And what this is? This is high temperature in Guwahati, medium, and low that they have given, right? This is given, right? Now what I'll do, and the set is nothing but HD, that high temperature in Delhi. Right, so it depends on this high temperature in Guwahati, medium or low. So that's how I have written these three terms. Right, that high temperature in Delhi given high temperature in Guwahati multiplied by what's the prior probability that it's a high temperature in Guwahati, plus similarly for medium, similarly for low temperature. Right, so if you put all the values, then math will work out to 0.6015. Right, so this is the main thing, that how to find out this high temperature in Delhi. You cannot simply sum that zero point 0.4 plus zero point 0.1 plus 0.01. No, right? Because the probability that it's high in Guwahati is different than medium temperature in Guwahati, then different than low temperature in Guwahati. Okay, guys. Any question? Any doubt? Anything? Okay, I will take it as all good.
Please explain the denominator part.
Sure. Okay.
How we are doing is actually this PhD calculation. How, I mean, how we are doing this?
Okay.
Yeah, yeah. This one.
Okay. Just a second. Control F. Array. Yeah. Okay. So just give me a second. Okay, now it's fine. Yes. So see, what we need to find out is what is the probability that it's high temperature in Delhi. Let me go to it from scratch. Right. So the high temperature in Delhi, high temperature in Delhi. There can be three ways. Like it can be either high temperature in Guwahati or medium or low, right? So this it is depend, see, how can you find out this high temperature in Delhi? It's not given in the data, right? All we know is the conditional probability. We don't know what's the probability that is high temperature in Delhi, but this conditional probability is given. Hd given hg, hd given mg, and hd given lg. Also the prior probability in Guwahati is also given, right? So from the data also you can understand that something like we need to use this LOTP, law of total probability. Or there are only three possible ways. No, if it is high temperature in Delhi, there are only three possible ways. It is similar as if I have my bulb faulty or capacitor faulty. There are like only three possibility. Either it is made in factory at Ahmedabad, or factory at Delhi, or factory at Hyderabad. Right? So there are only three possibility. So here there are only three possibilities. Either it can be high temperature in Guwahati, or medium, or low. That's how can we write it in probability, that Hd given Hg multiplied by Hg. So this is the same formula as the LOTP. A given B1 into probability of B1 plus A given B2 probability of B2 plus up to A given Bn probability of Bn. Right, so that's the same formula that we have applied to find out the probability of high temperature in Delhi. Till any doubt, guys?
So that is okay, Ramayan, but how we intuitively think about this? Like I have to calculate LOT, using LOTP during exam. Sometimes we get blank actually. How we calculate this?
Hmm. So always look for something in question that something is dividing your space or 100% probability in three parts. Right. So here these three are dividing your total sample space into three parts. Right. That high, medium, and low in Guwahati. Yeah, so this can give you one hint that we need to use this LOTP. Correct. And also, see, if only this is given, then it's not useful. You just need to know this conditional probability also. This is also given, right? Correct. So you can just look for this kind of a hint in the question also. If you're not able to generate that intuition that we need to apply this LOTP. And also, like, how many ways you can find out high temperature in Delhi probability of HD? How many formula you know? Probability of HD. How many formula we know? Probability of A. We know like this formula only, right? LOTP formula only. Or you can say something like this: A intersection B1 into A intersection B2, A intersection B3, like that. And from that, we just derive this formula basically using the that conditional probability formula. And so there is basically just one formula that to find out this probability, main probability. Correct.
Yeah.
Uh, just a second. Yes. Now some dessert we have after finishing this thing. Okay, let's enjoy.
So one hack that I do is like if you go talk to the
Uh huh.
so by reading the question, I think we should able to get this. Like if the question is mentioning that no, like A happened given B, and it's also saying that B happened given A, and also saying C happened given B in the combination, right?
Hmm.
Most probably you can assume that anyhow the numerator part will be easy. The denominator part is the you have to assume that this is the logic that you have to apply. I
Okay.
think by reading question, mostly we can get it. So I will try to explain why the denominator is in that way. Just give me something. Maybe when I am ready, I will let you know.
Okay, sure, sure, Veertija.
No, actually, I got some doubt actually.
Mm-hmm.
So for that, I need to I want to suggest that we should always stick to the basics. Like what is the very basic, very fundamental of probability is the number of favorable events upon total number of events. That is any kind of probability. That is the very basic thing.
Huh.
So here we can approach it like this, as Ritesh has said that it is clear that it is a question for conditional probability. So we will anyway use the naive Bayes or total probability formula. Now the last, sorry, no, that Bayes formula. Now in the denominator where Shahakar has doubt, so what is happening over there, we can turn it in that way. Like we have to determine the probability of having high temperature at Delhi.
Hmm.
So what we should do, what we would have done if it was have been a simple problem that we would have fixed it like total number of probabilities. I mean the total number of how many probabilities any kind of temperature is there. Like suppose there are high, given low, and suppose they are equally probable, then we would have done it like 1 by 3. The probability of having high temperature daily would have been 1 by 3. Okay, so that was the very basic thing. So here it is not given directly. So what we have given is Guwahati's temperature as you were explaining. So the probabilities which we are summing it up, they are actually the probabilities of happening that event, actually our favorable event, which is high temperature at Delhi. From the temperature which is high at Delhi, there are three events possible. I mean, three cases possible where the temperature can be high in Delhi. That can be high in Guwahati, that can be medium in Guwahati, and that can be low in Guwahati. So the probability of having high temperature in Guwahati, provided that the temperature is having high at Delhi, simple mg, and similarly for lg. So those three cases are basically the probabilities of our event to happen. I mean, our event is having high temperature at Delhi. So that is the very basic thing, that our event is happening in three types, in three ways. So the total probability of those three ways will be the total probability, or the probability of the our case, which is nothing but the high temperature at Delhi. So we can term it by that way if you want to understand it by the very basic point of view, or we have to make the relation between the very basic fundamental of
Yes.
probability and this.
Yes, that makes sense. Yes. Correct. Okay, guys. Any more doubt or something? Thanks, Sudeep. Like it was really good. You can say uh, explanation. Okay. Should we jump on to next? Uh, okay. So let's take the next one. Okay. Cool. So let A, B, and C be independent events which occur with probability zero point 0.8, zero point 0.5, and zero point 0.3 respectively. So these three are independent, right? So one has like no effect on second, second has no effect on C. And all three are having basically what's the main crux behind independent event is the sample space of A, B, and C are different. It can be like 126, 126, 126, but all three are different, right? So, and nothing is gone. If you're choosing a ball, like in event A, if you're choosing a ball, so all three boxes are different, something like that. That's a point 0.8, point 0.5, and point 0.3, the occurring event. The probability of occurrence of at least one of the event is, right? So, what is the probability that at least one of the event occurs? So, this is not the answer. Answer is something different, something like this. And I guess I should have written one formula. Ha, what is the meaning of at least something is happening? At least that I got a 6, at least I got 5, right? Or at least I get something like this. So it's nothing but 100% that it's not occurring, minus none, right? So if I'm say at least I get 5, so 5 and 6, that's my favorable, you can say, event or outcome, 5 and 6. So it's nothing but 100 minus none, right? So none, what is the meaning of none? That I don't get 5 and 6, right? I get 1, 2, 3, or 4, like that, correct? So it's 100 minus none. So if you want to find out at least I get 5 or 6, you can directly apply this formula. 100 minus is nothing but 1 minus none, right? It would be really easy if you go other way. That way also you can solve. You will just need one more paper, rough paper, but definitely you will get the answer. But we want to be like a horse, not other animal that do like more and more, you can say, thing. So this probability of A, probability of B, and probability of C are given, and all are independent, right? Point 0.8, point 0.5, and point 0.3. So this is just for the understanding that let's say they ask probability that all occurred, right? So this is nothing but the probability that someone, you can say, passed the mathematical exam, maths exam. It's a point 0.8, physics exam point 0.5, and chemistry exam point 0.3. Exactly my graph like in 11th 12th, right? And I say like probability that all occurred, that I pass in math, physics, and chemistry both, right? PCM. Then its probability is point 0.8, I pass in mathematics, into point 0.5 I pass in physics, point 0.3 I pass in chemistry, right? So it's 12% chance, right? So it's nothing but A intersection B intersection C. So P into PB into PC, because it's independent event. Probability that none of them occurred, that means I fail in math also, I fail in physics, and I fail in chemistry, I fail in all of them. Then what's the probability that I fail in math? Just 20%, point 0.2. In physics, point 0.5, point 0.7 for chemistry. So it's 7% chance that none of them occurred, I fail in all. Now what they are asking is at least one occurred. At least I pass in one, right? So that's why I told you that you will need to like at least one rough extra set, that at least one. So there are so many possibilities that I pass in math only. At least one they are asking now. So it can be one, two, or three. So at least one can be math, physics, math and chemistry. Only physics, physics and chemistry. Only chemistry. All this you need to you need to calculate. But if we use this smart formula that 100 minus none occurred, that means I don't pass in any of the paper, right? At least one. That means what's the opposite case that I at least one? So it's nothing but zero. I fail in every subject. So one minus p of none. So p of none that we already calculate, zero point 0.2 multiplied by zero point 0.5 multiplied by 0.7, 0.7, right? So the answer I get is 0.077%. So 1 minus 7%, 93%. So this is the answer. Correct? I guess this makes sense, right, guys? That at least equal to 1 minus none. Okay. I guess we have one more question. Question number.
Can I take it for a while? Can I share
yes,
my
yes,
screen?
go on. Okay, let me stop sharing.
Can you able to see my screen?
Not yet, but I guess now, yes.
Yes. Okay. Just sorry, 1 second.
How can I put it on focus mode? Full screen I have. Okay. Change layout, change background, spotlight. Yes, this makes sense.
Yeah. Okay, 1 second. Yeah, now you can see my screen, right?
Mm, yes, now I can.
Yeah, I think this example is good. Maybe by this I will get some clarity. So let's say
Can you
Hunter says,
zoom it a bit? Sorry to interrupt, but
yeah, yeah, sure.
okay,
Is it
okay,
fine now?
that's fine. Yes, very very good. Thank you.
Okay. Yeah. So let's say Hunter says she's itchy. There is a test for allergy to cats, but this test is not always true. So this is what they have given. So for people that really do have the allergy, the test says yes 80% of the time. Okay, and for the people that do not have the allergy, the test says yes 10% of the time. Okay, this is false positive. So if 1% of the population have the allergy and Hunter test says yes, what are the chances that Hunter really has the allergy? So by this we know that this is related to Bayes theorem, and we will. This is the main formula. So B probability of allergy given S is equal to P of probability of allergy into probability of S given allergy and divided by probability of S. So we know what is probability of allergy. They have given already like 1% of the population have the allergy, and we know what is probability of S given allergy by looking at this. So people that do really do have allergy, the test says 80%. What we don't have is P of S, right? So how do we find it? So they are saying we don't know the general chance of test saying yes, but we can calculate by adding up those with and without the allergy, right? So we know that 1% have the allergy and the test say yes to 80%. And also we know that 99% do not have the allergy and the test says yes to 10%. So basically, as we don't know the probability of S, we need to add all these false positives and false negatives. So by that we will get 10.7. So just need to submit over there and you will get the answer.
Hmm.
So I think this was a little bit clear, I guess. Do anyone have any doubts? Is it clear or not clear?
Yes, that helps. So basically, we are taking both the case to find out like what is the probability of yes. So it can
Yeah.
be 1% and 99%, right? So it is summing up to sample space basically. So 1% either you can have allergy, 99% you don't have. Right?
Since we
Okay.
don't know exactly what's the probability of S,
Yes.
but we know that it's saying, we don't care whether it's a false positive or false negative. We only care what is the probability of S. Since
Correct.
they are already saying, right? So this is false positive case, it's saying yes, and this is false negative case, it's saying yes. So basically add those.
First is true positive, no?
First,
It's an
it's true
allergy, and
positive,
we are saying yes.
Yeah.
Okay. Yes, that this makes sense and good example, because I was even bored with that cancer example that someone is having cancer and the test is 90% accurate. So this is good.
Maybe I will share it in
Sure, definitely.
maybe
That would be helpful.
someone read it. If someone has any doubts still, I think they read it, they can get it.
Cool, cool. Thanks for sharing. Gil. Okay, let me start sharing my screen again. Screen number 2. Change the layout to auto. Okay. Is my screen visible, guys? Hello.
Yes, yes.
Okay, so we solve this. A, B, C are independent events. So this is not the answer. Say copy paste. Nakal mein akal. Let's take the next one. 11. The probability that the number selected at random between 100 and 999, both inclusive, will not contain the digit 7. Right. So what we need to do is, see, these all are nothing but inclusive range, so all these things are nothing but 3-digit number only, right? So we need to find out that 7 is not there, right? So this is the pure you can say uh, probability question, that find out how many favorable way you have divided by total number of uh, you can say this thing, total number of events. That's nothing but total numbers you have, basically 3-digit number, right? So total 3-digit number we have, it's 900. Don't take 999 minus 100, right? So you just need to add 1. uh, that's nothing but if you count all the students from 11 to 21, roll number 11 to 21 both inclusive, it's 11 not 10, right? So 900 numbers we have total, and we need to find out how many numbers we have without 7, right? So that's nothing but finding out the permutation. uh, Hello, someone wants to ask something? Okay. Right, so we have this 3 digits. I guess it's called unit. What's this called? 10 and 100. Is it like that? Dash or
Unit 10
okay? Unit, tens and hundred. I have written in Gujarat. If someone is able to read it, I don't know. Ekam dasak. So right. So at this 100 place, we have only eight possible numbers. Why? Because we cannot put zero here. No, because it's from 100 to 999. It's not binary or something, right? So either you can put 1 2 3 4 up to 9. So there are 8 possibilities that you can put, 8 numbers, right? So we are basically counting and 7 is not also included, right? So 1 2 3 4 5 6 8 and 9, right? For this you can include 0 now. So 0 to 6 8 and 9, so they are nothing but 9 numbers you can put here. Then for this unit digit, you can again put 0 to 9, except 7, so 9. So how many total possible ways, like without having the number 7, is 648, right? So 648 out of 900 is nothing but 18 divided by 18 in 25. So this is the probability that number is without 7, right? So this was the trick, that you cannot put 0 here, correct? And also this is also easy to miss, that 999 minus 100, just add 1. Okay. I don't know how they are mixed up, but some examples are very easy in between, and some examples are tough also. Okay, let's take the next one. The bag contains 10 white balls and 15 black balls. Okay, two balls are drawn in succession, right? So two balls are drawn in succession, one by one, not two at once, right? That means order matters or not? Yes, definitely, because they are drawn in succession. First ball, then second ball, like that. The probability that one of them is black and the other is white is right. So I have two places, right? So you need to count that first ball is white, first ball, second ball is black. First ball is sorry, what they are saying is black and white. No, so first ball is white and second is black, or first is black and second is white, right? So just count that numbers, how many numbers you have, divide by how many ways you can choose, 10c2, 15c2, or you can directly say not 10c2 and 15c2. We have two place and we have 25 balls. No permutation we need to take, 25 multiplied by 24. So that are the total ways, right? So these are the total ways I have. Sorry, and how many favorable events I have. That first event is nothing but the first ball is white and second ball is black. Or even if you don't want to remember that, you can do something like this. I have two places to fill. The first place can be either white or either black. So if I have here white and here black, then it's nothing but I can put it like in 10 ways multiplied by 15 ways. Then again black and white. Sorry, then it's 15 into 20 10. So 150 is nothing but 300 divided by 25 into 24. So 1/2 chance that you choose like one ball is white and one ball is black. So probability of WB and BW, right? Or it is or, correct?
But if it was not in succession, so that means we would have this 25 into 25, right? In denominator.
Uh, Succession means I think once you have taken one ball out, you should minus it. I guess that's why it's 24.
No, if it's not in succession.
Okay, if we are
If
choosing
if
like
if the ball was
randomly.
again put
See,
put back to back.
okay. See, if it is something like this, that they say the bag contain 10 white balls and 15 black balls. Two balls are randomly chosen at a time from the bag. The probability that one of them is black and other is white. Now what would be the answer? So I have total 25 balls. So there are 25, choose two ways, right? So there are 25, choose two. So I can choose any of the two balls in 25 see two ways. So this is the total ways. Now what I'm saying is one of them is black and one of them is white. Here order doesn't matter, right? Because randomly I'm choosing two ball at once. Now that would be, I need to choose exactly one balls out of white, so 10c1, and one ball out of black, right? So our total black balls I have 15, 15c1. So this would be the answer then, right? I don't know. I'm not. Let's see how we can solve that also. So 25 c2 is nothing but 25 into 24 divided by r factorial 2 factorial. So this will go on. Then whatever the answer you get, right? So then this would be the case, but here it is in succession, so it's permutation basically, correct?
Yes, Shashank, I think you are correct. If it's not succession, we don't get 24.
Huh. In succession, like order basically matters, right? So the first ball is black and first ball is white. It's different. But if we are randomly choosing the ball out of the bag, two balls at a time, then it's like a proper, you can say, combination, not a permutation. Okay, let's take one more. Two dice are thrown simultaneously. The probability that at least one of them will have the six facing up, right? So many ways to solve this, but the favorite one word I have, at least, right? Not this, at least one. At least they are saying. So we know at least is nothing but 100% minus none. So 1 minus none. So what is the none? Exact opposite. One of them will have six facing up. That means none of them is having six facing up, right? So first dice not having six. That means 1, 2, 3, 4, or 5. So 5 out of 6 ways. Second dice also should not have 6, right? At least one of them. So none of them. So both of them are not having 6. So here also 5 by 6. So you get the answer 11 by 36. As simple as that. Correct? But if you go like in other way that find out all the possibility that one of them will having the 6 facing up, then it will take some time basically. Then you need to figure out all these 11 ways.
Or six. I think it's the sum of six, right?
No. At least one of them will have 6 facing up. That means one of the dice is having 6. Right. So and see, 11 is also very easy to count. That one is having 6 and others are having 1, 2, 3, 4, 5. Right. 1, 2, 6. Now the first dice is having 6 and other is having 1, 2, 6. So there are total 12 ways. But this 6 and 6 are common, right? This 6 and 6 doesn't make any sense. So minus 1. So 11 out of 36. Correct? Just take one more. Uh, I'm okay. How many we have left before that distribution questions basically? So many. So let's do like whatever we can do up to 11:30. Then the rest tomorrow. Question number 14. Okay. Proper signature, you can say probability question. The probability that top and bottom cards of a randomly shuffled deck are both aces. So it is as simple as asking that out of 52 cards, if I ask you to choose two at a random, what's the probability that both are aces, right? So both are A basically. So it's nothing but I have two, you can say, this thing. So how many ways like basically you can choose two cards, right? So first card if you choose it's 52 ways multiplied by one card is gone, right? So 51. So this is the total number of ways 52 multiplied by 51. Now I ask you like you need to choose both the S's. S. Then the first, how many ways you can choose? It's 4. 4s we have no A. Multiplied by 1 is gone. Now how many left? 3. So 4 into 3. Do we have something like that? Yes, 4 by 52, 3 by 51. Yes, C is the answer. And this is feeling like a toy example now. I guess they should have given these examples like as 1 to 10, then increase the gear. Okay, 15. The probability that it will rain today is 0.5. The probability that it will rain tomorrow is 0.6. I guess this kind of a question was there in exam, but Saturday and Sunday something was given like that. So the similar question was there in exam. So the probability that it will rain today is 0.5. Okay. Probability that it will rain tomorrow it's 0.6. Cool. Probability that it will rain either today or tomorrow. A union B is given, right? Either today or tomorrow. So both are combined. So it's 0.7, 70% chance. Cool. What's the probability that it will rain today and tomorrow? Intersection we need to find out. Simple formula A union B is A plus B minus A intersection B. I don't like this. I guess the question was altered, right? Edited to have that conditional probability. The similar question was there, but conditional probability was given. What was the question number? Question number 5. Rain today, rain tomorrow. RT and RTM. So I like this kind of notations to take. Right, point 5 and point 6. Rain today, union rain tomorrow. Either it will rain today or tomorrow. It's point 0.7. So I need to find out that it will rain today and tomorrow. Right, today and also tomorrow. So RT intersection RTM. Rain today, rain tomorrow. So we can just simply use this formula. Union is probability of individual probability sum of minus intersection. Alright, so intersection I can find out because I know 1, 2 and 3 terms. So it's 0.4. Okay, one more. The die is rolled 3 times. Cool. The probability that exactly one odd number turns up among the 3 outcome is cool. So exactly one odd number, right? So one should be odd. rest 2 should be even number. Right, that's cool. And the die is rolled 3 times, one by one. Right, so I have 3 tries. Cool. And how many ways, how many total ways I have? So it's nothing but 6 multiplied by 6 multiplied by 6. So that's correct. Now I need to find out, like, at exactly one odd number should be there. So one odd, two even. Okay, while writing this I realize odd can be second also. Right, so even, then odd, then even, it's also possible. And even, odd. So there are 3 ways. Let's find out one and multiply it by 2. 3, right? So what is the probability that I get odd number? It's nothing but 1 by 3, 1 by 2, 1 by 2 only, correct? Odd numbers 3, 1, 3, and 5. Even number 1 by 2. Even number 1 by 2. Multiplied by, okay, we are directly finding out the probability. 3, right? So 3 by 8, is it the answer? I guess we got directly the answer, 3 by 8, right? Otherwise, if you go to that way, 6 by 6 into 6 into 6, then we need to find out the ways, how many ways I can have, right? So let's try to find out that odd, even, even, right? So how many odd number I have? 3. How many even number I have? 3. How many even number I have? 3, 3, 3, right? And this odd number can be here also, and here also, right? So multiplied by again 3, divided by 6, 6, 6, 3, 3, 3 will gone, 3, 3, 3 will gone. I will have 8. 3 2 ja 6, 2 3 ja 8, 3 by 8. Again I get the same answer, right? So if you directly count the probability, take the multiplication, you get 3 by 8 as we saw. Or if you want to find out that classical way, find out the total number of events, favorable events, you get the same answer. uh, अरे जाने भाई हाँ. Cool. Just pardon me for this kind of stuff, but this is not needed basically. Okay. Next question. Question number 17. Okay. Consider the two events even in E2 such that the probability of E1, it's P or even, it's 1 by 2. Okay. Probability of E2, it's P or E2. Okay. It's 1 by 3. Why they have like gone from P to PR? And probability of even and E2, it's nothing but the intersection. Even E2 is 1 by 5. Which of the following statements is or are true? Okay, so first they are saying is E1 or E2. It's nothing but union. So we can find out the union probability also, right? E1 given, E2 given, intersection is also given. So 1 by 2 plus 1 by 3 minus 1 by 5 will give you my union probability. So the probability of that union is nothing but 19 by 30. So it's not equal to 2 by 3. So A is gone. As someone started to send me OTP right now. Like yesterday. Yes. Let me turn off the card, guys. I got 2 OTP and more are on the way, I guess. Yes. I need to learn that ethical hacking and cyber security basically right now to screw up this fellow. Okay.
Now you need to learn cyber law for that.
No. I don't believe in. Actually, say it will take more time. No, just learn hacking and show them like what I can do. Like every time, like this time, someone is like messing up every night. Like, yesterday it was around 10 or 10:30 maybe. Okay, let's see. That's fine. Okay, B. What's the option B? I just lost the track. Okay. Even intersection E2. Okay, what they have given? Even and E2 are independent. What's the meaning of even and E2 are independent? It's nothing but even intersection E2 should be multiplication is equal to should be this even multiplied by E2. Right? So this is the definition of independent event. Right? So let's see if we can get that. So where that I have calculated, probability of E1 multiplied by E2, it's 1 by 2 into 1 by 3 is 1 by 6, and it's not equal to E1 intersection like E2. So B is also incorrect, right? Let's take option D, that E1 given E2. I know it's wrong. Let's see. So E1 given E2, we can find out. See, this is the main formula that we are using for first time. The simplest formula, E1 intersection E2 divided by E2. Don't complicate it much because we know this intersection already, right? So it's 1 by 5 by 1 by 3, it's 3 by 5. And what they have given is, oh my god, let me erase this thing. So here what they are given is 4 by 5, E1 given E2, and what we are getting is 3 by 5. So D is also false. So for option C, it's even. What was the option C? That E1 and E2 are not independent. That's true. That's what we proved, right? Because E1 multiplied by E2 is not equal to E1 intersection E2. That means they are not independent event, right? And from this option, if it is MCQ, then either B can true, either C can true. No need to check for A and D, right? Because both are exactly opposite statement that are independent or not independent. One of them can be true, right? Both of them cannot be true, right? So just check for this condition B and C, and we are done, right? Next question. Okay, this is also easy. Even in E2O are the events in the probability space satisfying the following constraint. E1 is equal to E2. Probability of E1 is equal to E2. E1 union E2 is 1. So that's okay. And E1 and E2 are independent, right? In independent, okay. Now the value of probability of E1, the probability of the event E1 is. So what they have given is, this intersection is given. These two the probability of E1 and E2 are also same, and both are independent, right? So what's the probability of E1 they are asking, or probability of E2, because both are same. So how can we do that, right? So we know this formula that that this thing. How to turn on this? Okay, that union formula we know, right? Probability of E1 union E2 is probability of E1 plus E2 minus E1 intersection E2. Now, in this formula, I know this is equal to 1. They have given that E1 union E2 is 1, and E1 is equal to E2, right? So if I say this is equal to X, then this is also X. But this term I don't know, right? So for that term only, what they have made statement is E1 and E2 are independent, right? And from the independent, the law, like, or the definition of, like, both, if both events are independent, E1 intersection E2, it's nothing but probability of E1 dot probability of E2 multiplication, right? Basically, so x into x, x square. So this is also known. So 1 equal to x plus x minus x square, one equation, one unknown, we can solve that, right? So x equal to 1 we get at last. Correct? Any doubt in this? Then we will jump on to very good or good example. Okay, question number 19. 7 distinct car accident occurred in a week, right? So every accident are distinct. What is the probability that they all occurred on the same day, right? They all occurred on the same day. What's the probability, right? Now, just see, all occurred on the same day. And how many days in a we have in a week? 7, right? So either they can occur on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We have just 7 possible days, right? Okay, so if we can solve for one day, for Monday, or let's say any like for one day, if we can solve and multiply it by 7, then we can get the answer, right? So how can we solve that, right? So let's see, and see, and this is the one more intuitive way, that let's say it occurred on Wednesday, right? It occurred on Wednesday. Then how many possibility that we have, right? And see, total number of outcome, it's boring, we know. So let's see, like, if it occurred on Wednesday, then there is no accident on Monday, right? So it's just one way it can occur. 7 say 0, it's 1. No accident on Tuesday, 7 is 0, it's 1. No accident or Thursday, Friday, Saturday, and Sunday. So everything is 1. So 7, all 7 accident on Wednesday. So 7, C 7. Right? So out of 7 accident, I'm choosing all the accidents, 7 accidents. So it's again 1. But the choosing one of the day, it's nothing but I can choose it in 7 ways, either Monday, either Tuesday, Wednesday, or you can say, you can shuffle this thing in 7 C1 ways, right? So it's nothing but 7 ways. What's the meaning of shuffling? That choosing the accident day, right? Any of the day. So there are 7 days. So it's nothing but 7. So 7 multiplied by 11111, right? Now, how many total outcome I can have? Right? So I have 7 days and 7 accident to put, right? So all the accident can happen on Monday also, or let's say one of the accident happen on Monday, two on Tuesday, three on Thursday, sorry, Wednesday, then Thursday. So there are 7 to the power 7 ways, right? So I have all the 7 accident here, right? I can put 0 to 7, I can put 0 also, right? So again I have 7 accident in my hand, again 7, again 7, so total 7 to the power 7 total outcomes I have, right? So and how many are favorable? Actually not favorable in case of accident, but in case of probability, the favorable outcomes are 7 multiplied by all this thing 111, so it's nothing but 7. So 7 divided by 7 to the power 7 is 1 by 7 to the power 6. Right? So this is the probability that all occurred on the same day. Any doubt, guys?
Why is it 7 power 7? Can you repeat?
Why it's
7 power 7.
see, it's simple. You can say permutation. No, we have 7. You can say n equal to 7 basically. That 7 accident we have in our hand options, and there are 7 slots. Correct. And I am not saying that this thing the repetition is not allowed. Right. The first accident can happen on and everything is distinct. No. So it's possible that the accident number 1 can happen on Monday or Tuesday or Wednesday. So at each place I am having 7 ways. So it's the first thing that it's kind of that lock. If like 7 digit lock basically, right? So you can have either 0 to 7 here, 0 to 7 here, 0 to 7 here, like that. Correct. So for all the slots, I am having 7 possibility. That's why 7 to the power 7. Correct. Okay. Next question, question number 20. So the pace, I like this, like 20 question a day. It's good. 4 fair coins are tossed simultaneously. The probability that at least one head and one tail turn up is, right. So I have 4. Okay, why we have these kind of questions now? Okay, 4 fair coins are tossed simultaneously. The probability that at least one head and one tail turn up, right? So at least one head and one tail. So they are asking for this thing. At least one head. So there should be like head out of this 4. You can say 4 coin toss. There should be one head or two head or three head. It can be that, or and one tail should be there, right? So you cannot have all heads or all tails. What they are saying is at least one. So it can be one or more head. You can have either one, two, or three heads. And for tail also you can have one tail, two tail, or three tails. Right? Three tails. Correct. So what they are asking is the probability that at least one head or one tail turn up is. So it's I actually tried to solve it that way also. I guess it's 14 by 16, something like that. 7 8 7 by 8. 14 by 16. So if you put all the 16 possible ways, right? H like that. All the 16 ways. Only there are two, you can say, outcome out of 16, that there are not at least one head and at least one tail. And those two gentlemen are T. All other 14 ways are having either one, at least one head or at least one tail. Right? So how many are remaining? 14. divided by 16. So it's nothing but 7 by 8. Right? So see, this was easy to calculate because it was just four fair coin toss. But if they twist this bit and if the experiment is not easy to calculate, like number 12-digit number or 10-digit number like that, so what you need to calculate is what they are saying is at least one head and at least one tail. So at least is nothing but 100 minus none. So none is nothing but none. Like none of the like I don't have at least one head or at least one tail, and it's possible if everything is head or everything is tail. So 1 minus 1 by 16, 1 by 16, right? So it's nothing but 2 by 16. Two there are two ways, no? H, so 1 minus 2 by 16, so it's 7 by 8. Right? So whatever the way you got the intuition, but it should make sense, right? Okay. So this was the theory question for the sequential model. I think we should solve like one or more questions from that thing also. What you call that? Mid same paper, right? Because there were good questions on this thing. Because after that, I guess we have okay. Still, we have some some questions from probability. But let's try to solve that for a change. Assignment question. Sorry, that mid same question. Okay, appliedroutes.com. Pastes. Should I take it again? This is annoying, right? When we log in, they just change the URL. I don't know who does that. Midterm 2, yes. This one. There were good questions basically. Can we go to probability questions directly? Okay. I don't know how I solved that because let's see. A 10-sided dice, okay, 10-sided dice labeled with integer from 1 to 10 is rolled twice. Okay. If the rolls are independent, what is the probability that we get 5 followed by a 6? Okay, simple as that. We have two slots. What's the probability that I get 5 here? Right? So 10-sided dice is there. 1 to 10, I have 10 outcomes. So I need to get 5. So it's nothing but 1 by 10 multiplied by on second try I get 6. So it's again 1 by 10. So it's nothing but 1 by 100. Simple. Right? Easy starter, easy peasy. Let's take next covariance. This. Okay, good one. Box one contains one red ball and one white ball, right? So box one, let's say B1 contains how many red balls? One red ball and two white balls. Every time it's not black, it's white. Okay. Box 2 that's nothing but B2 contains two red ball and one white ball. Two red balls and one white ball. Okay, interchange. One ball is drawn randomly from box 1 and transferred to box 2. Okay, so I am choosing one ball from box 2 and transferring box 1 and transferring to box 2. Okay, then a ball is drawn randomly from box 2. So I am choosing a ball out of box 2. Okay, and it's red. Okay, and it's red, so the condition is given that red and it's from box 2, and I am choosing from box 2 and it is red, so it is given, right? It is red is already given. What is the probability that the transferred ball was white? Right, so what we need to calculate is that transferred ball is white. So how can we choose the events, right? So this is very tricky question. The event is that I transferred a ball, red ball, from box 1, right? So what is this? I transferred a red ball, right? And let's choose one more event, B. that I transferred a white ball from box 1. Right? So that's what they are asking, probability of B. Right? That I transferred. And what they are now, if like what is the probability that I transferred a box, that to W or white ball from box 1 to box 2. Now, they are saying that I choose a ball from box 2 and it's red, right? See, there is a simple mistake that we can make is, first I thought it should be 2 by 3 now, whatever the ball I choose from here. No, it's dependent. How? uh, let's take case one by one. Let's say I transfer red ball from here to here. One ball, there is a one ball that I transfer from here to here. Then how many red balls I have here? Three. Following me, guys? And one white ball, because I didn't transfer white, na? Then what would be the probability that I choose a red ball out of box 2? So it's nothing but 3 by 4. But there is one caveat. What happen if I transfer a white ball here, white ball from here? So what happen if I transfer a white ball from here? So if I transfer a white ball from here, then it's 2 2. Then the probability of choosing a red ball from box 2 is 1 by 2. 2 by 4 is 1 by 2. So what's the answer? 3 by 4 or 1 by 2? We need to consider both the case, right? So if I put a conditional probability, that what they are asking is, what's the probability that transfer ball was white? What's the probability that the transfer ball was white if the ball chosen from box 2 is red, right? From box 2 it's red, right? So if what's the, how can I write what's the formula for this? Probability of choosing a red ball given the transferred ball was white, multiplied by probability of choosing red ball, divided by, sorry, white ball, probability of transferring a white ball, divided by probability of choosing red ball. Alright. So probability of choosing red ball given the transfer ball was white. Right. So this is given that I transfer a white ball from here to here. Then what will happen? I will have two white, two red. So it's nothing but 1 by 2. This is trivial. This thing is trivial. 1 by 2. Multiplied by what is the probability that I transfer a white ball from here to here. Right? What is the probability that I transfer a white ball from here to here? Anyone? I just want to know if you're following or not. Anyone wants to give the answer? What's the probability that I transfer a white ball from box 1 to box 2?
1 by 2. 1 by 3.
Uh-huh.
1 by 1 by 2.
2 by 3,
2
no?
by 3. 2 by 3.
2 by 3, right? Because I need to choose one ball from here and put it in box 2. So it's 2 by 3 possibility, 2 out of 3, that it's white. Right? So these two are done. Always, this is the monster that I already told, right? That probability of R. And what are the case now? That we already know. That what is the probability that I transfer? Like there are two cases, right? For choosing a red ball. So this is the, you can say, the total probability of choosing a red ball, and it consists both case. So it is different than this, right? Probability of R given it's a white ball was transferred, so it's trivial, it's 1 by 2. If white was transferred, it's 2 2, then 1 by 2. What happened if I transfer a red? Because it's also probability that I need to consider if I'm talking about the total probability of choosing a red ball, right? So now let's work out probability of choosing red ball. What are the two cases? The ball transferred was white. Ball transferred was white, red, right? So I have one case, that probability that it was a red ball chosen, given I transferred a red ball from, and what is this symbol? I transferred red ball from box 1 to box 2, multiplied by the probability of transferring red ball, right? Let me erase this, plus probability of choosing a red ball given white ball was transferred, multiplied by probability of transferring white ball, right? And if you think like this is the formula that this term repeat in a denominator also. See, this is the exact term that I have here, right? So what is the probability that I choose a red ball from box 2, given red ball was transferred? So 3 divided by 4, that we just saw, right? 1 minute. Okay, 1 minute before, one is transferred here, so I have 3 red ball and 1 white ball, so 3 out of 4. What is the probability of transferring red ball from here to here? As you have guessed it, 1 by 3. Let me have LOC here. Probability of red given white. So it is as simple as this. It is the exact replica of numerator. No, numerator. 1 by 2 multiplied by 2 by 3. Right. So this is the denominator we got. If you work out the example, so you work out the math, you get the answer 4 by 7. So it's nothing but 0.57. Right. So this is the like this like at this level they can go like in the conditional probability formula also, right? But see, it was trivial, right? There are two cases. Like if we are choosing a red ball from box 2, there are only two cases, right? If red was transferred or white was transferred. That's how we can come up with this formula. Correct? Any questions? Any doubt? Anything?
Yeah.
And they have given this question in easy.
Joke of the day. Cool.
Yeah, just
That's
do
the reason it went wrong, you know.
at the time, the brain has to click it.
Exactly. Okay. And if you like if you are able to like make a sense of it, no, then it's trivial. But if we can't make a sense of it, like what is the probability of transferring a white ball, red ball, right? So basically, you need to think like this: that you are choosing a ball from box 1, and what is the probability of getting red ball, right? Then it's clear, like it's 1 by 3. Otherwise, this like individual probability, it won't click. Basically, the formula may click because literally there are only two cases. But just convert them into a sentence and choose your event like wisely, and don't hesitate to use like big, you can say, names also. Even in coding, like give a big name to variable, it's fine.
Like if you solve more problems, right? You will
Hmm.
get that sense. Like you will think
Yes,
in that
yes,
way.
yes, yes. Definitely, my first or big advice would be solve all 100 problems that are there on Gigs for Gigs. Then you'd be very confident. Like, give me any questions like that. Or like 7 or 8 questions are there that are purely from computer engineering, some kind of a database design, or I don't know what was that, networking and anything. So yeah, we can skip that. But still, we have like 30 to 40 questions. Good questions are there. Okay. Randomly distribution question we will see tomorrow. Say they've given this wrong, but I don't know like how to argue. The values on y-axis of PDF plots are probabilities. No one is saying that, but it's wrong. Also on CDF they are saying probability. It's also wrong. It's cumulative density. 329. What is this? Oh, okay, cool. So this would be the last question, guys, and tomorrow we will start with the question number 12. Or yes, right. So let's take this question. I can't wait. I can't help. It's fine, no, guys. Or are you feeling tired, guys? Should we stop here or take the last one?
So we can take one more question.
Okay, cool.
Sorry.
That's the spirit. A restaurant offers a choices of appetizer. I guess it's a welcome drink or something. 10 choices of main course. Cool. 4 choices of dessert. Great. Each of appetizer, main course, and desserts are consider one course in a meal. Right. So this is course one, course two, and course three. That 3 course dinner, 4 course dinner, 7 course like that. Right. A customer can choose to eat just one course, two different course, or all 3 courses in a meal, right? So he can either choose just one course, right? only appetizer, only main course, or only dessert, right? If it's with family or if it's just with girlfriend or wife, like that. Assuming that all food choices are available, how many different possible meals does the restaurant offer? Great. So it's like trivial that we need to calculate all the possible ways if one has to choose just one course, two different courses, or three, all three, right? So just first take like the one, just the one you can say course, that just one course. Then how many choice we have, right? How they have solved this. 5 choice 10 plus 4, why okay, huh? So if we just take one course, then how many ways we can take? One of the appetizer, or one of the main course, or one of the dessert. So there are 5 plus 10 plus 4. So how many ways we have? 5 down the zone is 19, plus let's calculate two different courses, right? So I have two places to fill, and I have like I can fill it with out of this three I need to choose two, correct? So I can choose like one appetizer and one main course, or one main course and one dessert, or appetizer and dessert, right? So there are like three possible ways only out of three. So first is nothing but if out of five appetizer I choose one, multiplied by one main course, so it's nothing but 5. So there are 50 ways I can choose something like this, the appetizer and main course. Cool. Then I can choose either appetizer and dessert also. Just keep the main course. So 5 multiplied by 4, 20. Then 10 of main course, and just take the dessert, 14. Right? And I should not consider main course and appetizer differently, right? Because it's all same. Appetizer and main course is similar as main course and appetizer, right? Because I need to choose two out of them, two different course out of them. So if you sum it all, I get 5 में 7 में 4 11 110, right? Plus I hope like this is correct. Now three courses in a meal, right? So there is just one way, that out of 5 appetizer I need to order one, right? Anything out of 10 main course, I need to order one. 5 into 10 multiplied by out of 4 desert, just take one. Star pancha is that one. So I have total 200 ways. So if I sum all this thing, I get 329, right? So just the counting question. This can be easy, like it should be marked as easy, but just a counting question, right? So they are just taking if we know permutation or not, nothing else. Any doubt in this question, guys?
I had used combination with repetition actually. That's why I was getting wrong answer. The
Okay.
note is given, na, like you can choose only one option. The note is clear why that way only, na, you.
Okay. I guess in two different course you must have taken appetizer, main course, and this. So 3C2 you must have taken or something like
No,
that. Or
actually what I was doing with repetition means like one appetizer. We are choosing one appetizer and one. I mean, we are taking only one choice, like 5 appetizers and 10 main courses.
Okay.
Uh,
I,
so it is
I
given.
I thought you chose two appetizer also. Consider two appetizer also, right?
Exactly.
No. Two different courses they you mentioned, no.
Uh,
Okay. Okay. Any questions, any doubt, or any general query in combinatorics? Let me stop recording.